Have you ever tried to imagine compressing the entire universe, every galaxy, star, planet, and atom, into a point smaller than an atom itself? It seems impossible, yet 13.8 billion years ago, that's exactly how everything began. In that infinitesimal point lay all the matter and energy that would eventually become our vast cosmos. The explosive force that followed was so monumentally powerful that we can still detect its echoes reverberating through space today. This isn't just another story. This is the story of the greatest event ever to occur, the birth of the universe itself. Picture yourself at the dawn of creation, at the very first moment when space and time themselves sprang into existence. The temperature was unimaginably hot, billions of times hotter than the core of the hottest star we know today. The density was infinite, with all of existence compressed into a space smaller than the smallest subatomic particle. This moment marked the beginning of everything we know, the birth of space, time, matter, and energy. Today, we're embarking on an extraordinary journey back to this moment of creation. We'll unravel the mysteries of the Big Bang Theory, examining the compelling evidence that supports this revolutionary understanding of our cosmos. Together, we'll explore how this infinitesimal moment of creation set in motion the cosmic dance that would eventually give rise to galaxies, stars, planets, and even life itself. We'll discover how scientists pieced together this remarkable story, and why the Big Bang Theory represents one of humanity's greatest intellectual achievements. If you're as captivated by the mysteries of the cosmos as we are, then you're in the right place. This is Exploring the Universe, where we delve deep into the most profound questions about our existence. Make sure to subscribe to our channel and hit the notification bell to join us on this cosmic adventure. Together, we'll unlock the deepest secrets of the universe, one discovery at a time. Whether you're a seasoned astronomy enthusiast or just beginning to explore these cosmic mysteries, this journey will forever change how you see your place in the universe. Let's begin our exploration of the most important event in cosmic history, the moment when everything we know came into being. To truly grasp the concept of our expanding universe, let's step into your kitchen for a moment. Imagine you're baking a raisin bread. As the dough rises in the warm oven, something fascinating happens. Every raisin moves away from every other raisin. The raisins themselves aren't moving through the dough. Instead, the dough itself is expanding, carrying the raisins along with it. This simple analogy perfectly illustrates how our universe expands. Just like those raisins, galaxies aren't moving through space. Rather, space itself is expanding, carrying galaxies along with it. Now let's venture back to the most extraordinary moment in cosmic history, the zero moment of our universe. Before this instant, there was no before. There was no space, no time, no matter, and no energy. At least not in any form we can comprehend. Everything that would become our universe was concentrated in what scientists call the initial singularity. This singularity defies our everyday understanding of physics. Imagine all the matter and energy of our current universe, every galaxy, every star, every planet, every atom, compressed into a point infinitely dense and inconceivably small. The temperature at this moment was essentially infinite, so hot that not even atoms could exist. In fact, it was so hot that none of our current physical laws could operate. The four fundamental forces we know today, gravity, electromagnetism, and the strong and weak nuclear forces, were unified into a single supreme force. The conditions in this initial state were so extreme that our current mathematics breaks down when trying to describe them. We're talking about temperatures in excess of 10^32 degrees Kelvin. That's 100 billion degrees. At these temperatures, the concepts of space and time as we understand them become meaningless. Our best physical theories, including Einstein's theory of general relativity and quantum mechanics, can't fully explain what was happening at this moment. This is where we encounter one of the most humbling aspects of cosmology, the edge of human knowledge. The extreme conditions at the zero moment represent a boundary beyond which our current physics cannot peer. It's a reminder that despite our remarkable scientific achievements, there are still profound mysteries at the heart of our universe's story. The most fascinating aspect of this initial state is that it contained within it all the properties and parameters that would eventually allow for the emergence of stars, planets, and even life itself. Like a cosmic seed, it held all the potential of our universe, waiting to unfold in a precise and remarkable way. Every atom in your body, every particle that makes up the Earth, and every photon of light streaming from distant stars was once part of this incredibly dense, hot state. What triggered this singularity to expand into our universe? What caused the Big Bang itself? These questions remain at the frontier of modern cosmology, representing one of science's greatest remaining mysteries. But what we do know is that from this moment of infinite density and temperature, our universe began its remarkable journey of expansion and cooling, setting the stage for everything that was to come. This zero moment marks not just the beginning of our universe, but the beginning of time itself. It's the ultimate starting point of every story we can tell about our cosmic history, the moment when the clock of our universe began to tick. In the aftermath of the zero moment, the universe embarked on the most dramatic transformation in cosmic history. Each fraction of a second unfolded like an intricate cosmic dance, revealing new fundamental aspects of our universe. Imagine unwrapping a series of presents, each one containing a new fundamental piece of reality itself. Let's journey through these first crucial moments that shaped everything we know. Our story begins at an almost incomprehensibly small unit of time, the Planck era, lasting just 10 brief to 43 seconds after the Big Bang. This unimaginably brief instant represents the smallest meaningful unit of time we can conceive. To put this in perspective, if we were to expand this tiny fraction of a second to the size of our entire solar system, a single atom would appear larger than our sun. During this era, the universe was so incredibly hot and dense that all four fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, were unified into a single superforce. As the universe expanded and cooled, reaching 10 to the power and 36 seconds, the first major transformation occurred. Gravity separated from the other forces, becoming the distinct force we know today, the force that keeps planets orbiting stars and shapes the large-scale structure of our universe. This moment marked the end of the perfect symmetry that had existed in the universe's earliest instant. The next crucial milestone arrived between 10:36 and 10:32 seconds during what cosmologists call the inflationary period. In this brief moment, the universe underwent an explosion of growth so rapid it defies imagination, expanding faster than the speed of light itself. Space inflated from a size smaller than an atom to about the size of a grapefruit, an increase in size of at least 10^78 times. This exponential expansion smoothed out the universe and created the large-scale uniformity we observe today. As we reached 10^12 seconds, another fundamental transformation occurred. The strong nuclear force separated from the electro-weak force, establishing another distinct fundamental force of nature. The universe was still incredibly hot, about 1016 degrees Kelvin, and filled with a soup of quarks, antiquarks, and gluons, the building blocks of protons and neutrons. By 1 microsecond, 10^6 seconds, the universe had cooled enough for quarks to begin combining into protons and neutrons. This marked the birth of the first stable matter particles, the seeds of all atomic nuclei that would eventually form everything from stars to the atoms in our bodies. The first 3 minutes were particularly crucial. During this time, the universe cooled enough for protons and neutrons to combine into the first atomic nuclei, primarily hydrogen and helium. This process, known as primordial nucleosynthesis, determined the initial chemical composition of the universe, creating the raw materials from which the first stars would eventually form. Each of these moments was like opening a cosmic gift, revealing new fundamental aspects of our universe. The precision with which these events unfolded is astounding. If any of these processes had occurred slightly differently, our universe as we know it wouldn't exist. And now, we'd love to hear your thoughts on one of the most intriguing questions in cosmology. What do you think existed before the Big Bang? Was there absolute nothingness? A previous universe? Multiple universes? Share your theories in the comments below. Let's explore these profound mysteries together. Remember, these first moments after the Big Bang weren't just ancient history. They were the crucial moments that determined the fundamental nature of our universe. Every atom in your body, every star in the sky, and every galaxy we can see exists because of the precise way these early events unfolded. While the Big Bang Theory might sound like science fiction, it stands on solid scientific ground, supported by three powerful pillars of evidence that have revolutionized our understanding of cosmic history. Let's explore these remarkable discoveries that validate our universe's explosive origins. The first compelling evidence came from Edwin Hubble's groundbreaking observations in the 1920s. Working at the Mount Wilson Observatory with what was then the world's most powerful telescope, Hubble made a discovery that would forever change our view of the cosmos. He noticed that distant galaxies were moving away from us, and not just in random directions. The further away a galaxy was, the faster it appeared to be receding. This relationship became known as Hubble's law, later renamed the Hubble-Lemaitre law to acknowledge the theoretical work of Georges Lemaitre. To visualize this expansion, imagine drawing dots on the surface of a balloon. As you inflate it, every dot moves away from every other dot, with greater distances between dots expanding more quickly. This simple demonstration perfectly illustrates how space itself is expanding, carrying galaxies along with it. The discovery of this universal expansion was the first crucial evidence suggesting that if we reverse time, everything in the universe must have originated from a single point. The second and perhaps most dramatic evidence comes from what we call the cosmic microwave background radiation. Quite literally, the afterglow of the Big Bang itself. This remarkable discovery occurred entirely by accident in 1964, when radio astronomers Arno Penzias and Robert Wilson were working with a sensitive microwave antenna at Bell Labs. They detected a mysterious, uniform background noise coming from every direction in the sky, which couldn't be eliminated even after meticulous cleaning of their equipment, including removing what they famously described as white dielectric material, or in other words, pigeon droppings. What they had stumbled upon was radiation left over from when the universe was just 380,000 years old. At that time, the cosmos had cooled enough for electrons to combine with protons, forming the first atoms and allowing light to travel freely through space for the first time. This ancient light has been traveling through the expanding universe ever since, its wavelength stretched by cosmic expansion until it now appears as microwave radiation. When we map this radiation, we see tiny temperature variations that provide a baby picture of our universe, showing us the seeds that would eventually grow into the galaxies and galaxy clusters we see today. The third pillar of evidence lies in the abundance of light elements in the universe, particularly hydrogen and helium. When we look at the chemical composition of the cosmos, we find that about 75% is hydrogen and 25% is helium, with only traces of heavier elements. This precise ratio of elements couldn't have been created in stars. It could only have been produced in the extremely hot and dense conditions of the Big Bang. During the first 3 minutes after the Big Bang, in a process called primordial nucleosynthesis, the universe was hot enough for nuclear fusion to occur everywhere, not just in stellar cores, as happens today. This cosmic fusion factory produced helium from hydrogen in very specific proportions. The fact that our observations of the universe's chemical composition match exactly what our Big Bang models predict is powerful evidence for the theory's validity. The abundance of light elements also explains why hydrogen is so prevalent in our universe. This wasn't just a cosmic coincidence, it was a direct result of the rapid expansion and cooling of the universe, which effectively froze out the nuclear fusion process before it could convert all hydrogen into heavier elements. This fortunate circumstance provided the raw material for stars to form and continue the process of element creation through stellar nucleosynthesis. These three independent lines of evidence, cosmic expansion, background radiation, and element abundance, form an interlocking framework that strongly supports the Big Bang theory. Each piece of evidence tells part of the same story, creating a coherent picture of our universe's origins that has withstood decades of scientific scrutiny and testing. Like detective work on a cosmic scale, these clues have allowed us to piece together the greatest story ever told, the story of our universe's birth and evolution. Just when we thought our understanding of the Big Bang couldn't get more exciting, modern science has unveiled new discoveries that push the boundaries of our cosmic knowledge even further. Perhaps the most stunning breakthrough in recent years has been the detection of gravitational waves, ripples in the fabric of space-time itself. In 2015, the LIGO experiment made history by detecting gravitational waves from colliding black holes. But cosmologists believe there's an even bigger prize waiting to be found: primordial gravitational waves from the Big Bang itself. These ancient ripples in space-time would carry direct information from the universe's first fraction of a second, potentially offering us a window into the very moment of creation. It would be like hearing the first cry of the newborn universe. The search for these primordial gravitational waves has led scientists to develop increasingly sophisticated detection methods. If detected, these waves would provide smoking gun evidence for a theory called cosmic inflation, a brief but crucial moment when the universe expanded faster than the speed of light. This period of explosive growth would have produced gravitational waves with a distinct signature that we might finally be able to detect with next-generation instruments. But these discoveries have opened the door to even more mind-bending possibilities. Modern theoretical physics suggests that our Big Bang might not have been a singular event. The theory of cosmic inflation, combined with quantum mechanics, points to the possible existence of a multiverse, an endless cosmic landscape where new universes are constantly bubbling into existence, each with its own Big Bang moment. Imagine our universe as just one bubble in an infinite cosmic foam, each bubble representing a different universe with potentially different physical laws and constants. This concept of the multiverse isn't just science fiction. It emerges naturally from our most sophisticated mathematical models of the early universe. According to these theories, the same quantum processes that caused our universe to inflate might be happening eternally, creating new universes in an endless cascade of cosmic creation. Each universe might have different fundamental constants, different physical laws, and perhaps even different dimensions. Yet despite these remarkable theoretical advances, we still face profound questions that challenge the limits of our understanding. The most fundamental of these is deceptively simple. What caused the Big Bang? What triggered that initial moment of creation? And perhaps most puzzling of all, what, if anything, existed before? These questions push us to the very edge of science, where physics meets philosophy. Some theorists propose that our universe might have emerged from the collapse of a previous universe, in an endless cycle of cosmic death and rebirth. Others suggest that the very concept of before the Big Bang might be meaningless, as time itself began at that moment. Still others propose that our universe might have quantum-tunneled into existence from a pre-existing state we can barely comprehend. The concept of quantum fluctuations in a vacuum state has led to intriguing possibilities. Could our entire universe have emerged as a quantum fluctuation in a higher dimensional reality? Could it be one of countless such fluctuations, each giving birth to new universes? These ideas blur the line between science fiction and cutting-edge physics. We're living in an extraordinary time when new technological advances are bringing us closer to answering these fundamental questions. Future space telescopes, gravitational wave detectors, and particle accelerators promise to push our understanding even further. The detection of primordial gravitational waves, if achieved, would give us our first direct glimpse of the universe's earliest moments, potentially revolutionizing our understanding of cosmic origins. Yet perhaps the most remarkable aspect of this scientific quest is how it highlights both the power and limitations of human understanding. With each new discovery, we push back the boundaries of knowledge, only to find new mysteries waiting to be solved. The story of the Big Bang reminds us that we are part of something far greater than ourselves, a cosmic drama that continues to unfold in ways we are only beginning to understand. These questions about our cosmic origins aren't just academic curiosities. They touch on the deepest mysteries of existence itself. As we continue to explore these frontiers, we're not just learning about the universe, we're discovering our place within it, and perhaps ultimately understanding something profound about the nature of reality itself. In the vast cosmic drama of the universe's birth, we find ourselves in a profound and humbling position. Every single atom that composes our bodies carries within it an extraordinary cosmic history, a journey that began in the most extreme conditions imaginable during the first moments after the Big Bang. We are not merely observers of this cosmic narrative. We are active participants, living embodiments of the universe's most incredible story. Think about the remarkable journey of the atoms that make up your body. They were present in that initial singularity, compressed into an infinitesimally small point of infinite density and temperature. They survived the violent expansion of the universe, the separation of fundamental forces, and the complex processes of atomic formation. These same atoms have been part of stars that lived and died, witnessed the formation of galaxies, and traveled across billions of light years before finally becoming part of your physical existence. When we say we are made of stardust, it's not just a poetic metaphor. It's a scientifically precise description of our cosmic origins. The carbon in your muscles, the calcium in your bones, the iron in your blood, all of these elements were forged in the nuclear furnaces of stars through processes of stellar nucleosynthesis. Those stars, in turn, were born from the primordial hydrogen and helium created in the first minutes of the universe's existence. In a profound sense, we are the universe experiencing itself. We are conscious beings who have evolved the ability to comprehend our own origins, to look back in time through telescopes and scientific theories, and to understand the incredible sequence of events that led to our existence. Each of us represents a unique configuration of atoms that have traveled an unimaginable cosmic journey, now capable of contemplating that very journey. This perspective transforms our understanding of humanity's place in the cosmos. We are not separate from the universe. We are an integral part of it. Our consciousness, our ability to wonder, to explore, and to understand is the universe's way of becoming aware of itself. Every scientific discovery, every moment of curiosity, every attempt to understand our origins is the universe examining its own incredible story. The atoms in your body have witnessed the birth of galaxies, the formation of solar systems, and now reside in a complex biological system capable of understanding these very processes. You are a living, breathing testament to the universe's incredible capacity for complexity, creativity, and self-reflection. In you, the cosmos has produced a being capable of looking back and understanding its own magnificent story. The Big Bang is far more than a scientific theory confined to textbooks or academic discussions. It is the foundational narrative of everything we know and experience, the ultimate origin story of our cosmic existence. This is not just a tale about the distant past. It is the first, most crucial chapter in the most expansive book ever conceived, the story of the universe itself. From that infinitesimal point of infinite density to the vast, expanding cosmos we observe today, the Big Bang represents a continuous, unfolding drama of creation. Every galaxy, every star, every planet, and every living being, including you and me, emerged from the precise, intricate choreography of physical processes that began in those first moments after the universe's birth. Our existence is a direct consequence of those initial conditions, a testament to the extraordinary complexity and potential inherent in cosmic creation. What makes this story truly remarkable is not just its scientific precision, but its profound philosophical implications. We are not separate from this cosmic narrative. We are its living, breathing manifestation. Our ability to contemplate these origins, to develop scientific theories that can peer back to the universe's earliest moments, is itself a wonder emerging from that initial explosion of potential. As we stand at the frontier of scientific understanding, we realize that the Big Bang is an ongoing process. The universe continues to expand, evolve, and create. Each discovery pushes the boundaries of our knowledge, revealing new mysteries even as it answers old questions. We are witnesses to a story that began billions of years ago and continues to unfold with each passing moment. If this cosmic journey has captivated your imagination and expanded your understanding of our universe's origins, we invite you to be part of this continuing exploration. Share this video with fellow cosmic adventurers. Leave a like to support our mission of scientific storytelling and subscribe to our channel. Hit that subscribe button and join us as we continue to unravel the most profound mysteries of existence. The story of the universe is still being written, and you're invited to be a part of its unfolding narrative.